Hi, in the previous video you saw how to find probabilities using Binomial PDF, and in this video I'm going to demonstrate the function Binomial Cdf, which computes probabilities and sums them too in one step. Now, as you saw, Binomial Cdf is the function after Binomial PDF in the distribution menu. Let's go take a look at that once more. The keystroke shortcut for Binomial Cdf is the alpha character B on the 84 models, and then on the 83 models it's the alpha character A. But since I've got it highlighted right now, I'm going to go ahead and press enter to put it on the main window. To show you how it works, I'm going to first do an example that I demonstrated in the Binomial PDF video. And you'll recall the setup was this. In 2008, among students taking classes primarily online at Front Range Community College, 80% of them were enrolled part-time. Then we take a random sample of 10 students taking classes online, and the question we're asked is this: what's the probability that no more than 2 of those students are enrolled part-time? The wording here, no more than 2, translates into x values of 0, 1, or 2, and what we need to compute is this quantity, the sum of the probabilities of x equals 0, x equal 1, and x equal 2. Now, how Binomial Cdf works is this. You'll note in the function name that the C stands for cumulative, and what it does is it accumulates the probability starting with the probability of x equal to 0. And that's where we're starting with this problem. We're starting with the probability of x equal to 0, and we're summing up to and including the probability of x equal to 2. So how you would specify this quantity in a command is like this: Binomial Cdf n comma p, and then the x value you give it is the highest x value in the range that you want to sum. So this is the quantity I'm going to enter in the calculator. N comma p comma 2. And you may recall that this is the same result I got using Binomial PDF in 3 steps, and it was approximately 7.8 times 10 to the negative 5th. Okay, so that's one example of how to use Binomial Cdf to compute a sum of probabilities. Let's do another example. Here's another question. What's the probability that 8 or more of the 10 students are enrolled part-time? Now, the actual calculation part of this question is easier to do than trying to understand the reasoning behind it, but I'm going to try to explain it here. 8 or more translates into x values of 8, 9, or 10. And so the quantity we're looking to find is the sum of these 3 individual probabilities, p of 8, p of 9, and p of 10. And in order to use Binomial Cdf to compute this quantity, what I need to remember is my complement rule. Let's first recall that the sum of all of the probabilities of any distribution is going to be equal to 1. And you'll note that the 3 quantities I'm interested in, p of 8 through p of 10, are the last 3 terms on the right side of this equation. So basically my strategy is this. I start with 1, and then I subtract off the probabilities that I don't want. And those are the probabilities p of 0 through p of 7. Now, how I do that is to recognize that p of 0 through p of 7 can be computed in this way: Binomial Cdf n comma p comma 7. So that one expression replaced those 8 terms that I don't want. And now what I do is subtract that off of 1, and what will remain is the sum of the probabilities that I do want. So this quantity on the right is what I'm going to enter into the calculator. I'm going to go grab my Binomial Cdf function out of the distribution menu again, and I give it n comma p comma 7, and now when I press enter, in one step it computes the sum of those individual probabilities and returns a result of about 68%. Okay, so those are the 2 demonstrations I wanted to do about how to compute probabilities for ranges of x values. In closing, let me just suggest this, that you might want to start off working these types of problems using both methods, using Binomial PDF in a few steps and then Binomial Cdf. And then when you can get consistent results between the 2 methods, you're probably ready to rely on Binomial Cdf by itself.